All right. Now, let's think about for a second something that we've talked about in the past that you may have forgotten. Okay, let's talk about absolute values for just a second. I want to just sort of retouch on what absolute values are. Okay, you should know what absolute values are. We've been dealing with them ever since, basically the first 2 weeks of school. But when I have the absolute value of x is equal to 8, okay, the absolute value of x is equal to 8. Okay, then what can x be equal to? Caleb.
8 or -8.
Correct. 8 or -8. So, if I use that same thinking, okay, absolute value doesn't change. If I use that same thinking, then this I have the absolute value of x plus 4 equals 8. If I use that same thinking, okay, then whatever's inside the absolute value can be either positive or negative. Okay? So, by our thinking here, we said this was 8 and -8. Okay? Well, the same thing holds true here. This is either 8 or -8.
If absolute value is with positive, how is it negative? If absolute value is with positive, how is it negative?
What I am saying is this, is that this value here, whatever that equals, could be negative or positive. Okay? Because we said here that the value of x is either 8 or -8, because I'm taking the absolute value of it. Okay? So, the only way then that I can take an equation like this and say that it's either a positive or a negative is to do this right here. Okay? That's the only way that I can solve this. And what I'm really doing is this. This right here is really saying x plus 4 equals -8. Okay? I'm not saying that this is going to be a negative, an absolute value is going to be a negative. Okay? Maybe took a step, got a little ahead of myself. Okay? What I am saying is this expression is going to be written like this to find out what it equals. Because, here's the issue. If I take this and I solve it, the only way that I can solve it is that I have to get rid of the absolute value sign. It's the only way I can solve it. Okay? To get rid of the absolute value sign, I have to set the equation equal to the positive answer of it and the negative answer of it. Okay, and that's what I've done with those two expressions. Now I just solve it. X plus 4, that means x is equal to what? Here. 4. Okay? What's it mean x is equal to here? Do what? -12. Okay, let's see if that's true. If we plug that back in to our original equation, okay, terrible 8. Okay, because what we are saying for this to be equal, and this gets back to your question, Zach, for this to be equal, both sides of this equation must be equal, right? Both sides must express the same answer. For both sides to express the same answer, it would have to look like this. would have to look like that right there. Okay? And for this to be true, I'd have to set it equal up here as well. So I'm no longer figuring the absolute value. I'm finding whatever the value of x is. Okay? So if we plug those in, we plug those two values in, that gives me negative 12 plus 4, absolute value equals 8. Well, what is negative 12 plus 4? Negative 8. And that's the absolute value of negative 8 is equal to 8. And that is a true statement. Okay, so that's the first one. Second one was, what was it? 4? Yeah. So the second one, we have x plus 4 equal 8, and that's the absolute value, which means 4 plus 4 equals 8. Absolute value of 8 is equal to 8. So they checked out. Okay? The equations are fairly simplistic. Okay? Inequalities get a little bit more difficult, but not really. They're basically the same. Okay? Let's look at another example.
So what's the answer?
The answer is, for this problem, was negative 12 and 4. That's your answer. Doesn't matter if you list the negative first or second. 4 and negative 12 are exactly the same. Okay? Let's look at another example. Let's say I had this, x minus 5. The absolute value of x minus 5 equals, almost gave you the answers, 2. X minus 5 is equal to 2. So the only thing you have to do is this. You simply take that problem and we say x minus 5 is equal to 2 or x minus 5 is equal to negative 2. Okay? Now, you have to solve them. Okay? So if we solve the first one, x minus 5 equal 2, what is x going to be equal to? 7. So we're just simply taking this 5, however we want to say it. We're either taking minus 5 and adding 5 to both sides, or we're changing that to x plus negative 5, and we're taking the negative 5 and making it a positive over here. Whatever way you want to solve it, whichever way you see it in your mind, do it that way. Okay, I know some of you like just, circling it and taking it over. It's a negative here, it becomes a positive over there. That's fine. Okay? Now, what is the answer to the other one? What? 3. Negative 3? Negative 3? That's plus a negative. Take it over there, becomes a positive. It's a negative here, positive there. So that's a positive 5, which means 3. So 7 and 3. Okay? Now, it does not change if you have decimals. It doesn't change if you have multiple steps in the equation. For example, if I have 4x minus 2, absolute value of 4x minus 2 is equal to 22. Okay? It doesn't change how you start the problem. Okay? If that was just 4x minus 2 without the absolute value signs, then you would just start solving it. The only difference between the two is here we must say this. 4x minus 2 is equal to 22, or 4x minus 2 is equal to negative 22. Okay? That's all we have to say. Okay, now we just solve it. Take this 2 over there, and you're adding 2. That would be 24. So it's 4x equal 24, which means I have x equal to X would be equal to 6. Okay, now, same thing here. Take that over, add 2 to negative 22, and that's 20. So you get 4x equal to 20, so x is equal to negative 5. So 6 and negative 5 is your answer.
So is the rest of it just for checking your work? The rest of it that we did, the first one?
Yeah, I was just checking to make sure that I came up with the correct answer. Okay, and you would do the same thing here. You'd plug in the 6. 4 times 6 would be what? 24. Okay, so 24 minus 2 would be 22. The absolute value of 22 is equal to 22. Okay, so same deal. Okay, and then you'd plug in negative 5. 4 times negative 5 is negative 20. Negative 20 minus 2 would be equal to negative 22. Absolute value of negative 22 would be 22. Okay, so that would be the answer as well. Okay, now, do this one on your own. It's a little bit more, it's not difficult, it's just a little more difficult. Let's see here. Where'd it go? There it is. X minus 3.2 absolute value equals 7. Do that one on your own. Now, who's got the answer? All right, Lake, what'd you get? 10.2 and negative 4.2. Yeah, what was that? What was it again? 10.2 and negative 4.2. 10.2 is correct. You missed the second one. What'd you get, Caleb?
Negative 3.3.
Nope. Missed it. Zach?
Negative 3.8.
Negative 3.8. So it is 10 and negative 3.8. So that gives me x minus 3.2 equals 7, or x minus 3.2 equal negative 7. Okay, once again, this is plus a negative, plus a negative. So I take this over here, becomes a positive 3.2. Then we're going to line them up, That gives me 10.2. Same thing here. It is a negative. So here it becomes a positive. So that's a positive 3.2, which means I have to take 7 minus 3.2. Be 0. And that would be borrow 6, 10, be 8, bring down my decimal. 6 minus 3 is 3. And the larger one is negative, so negative 3.8. So 10.2 and negative 3.8. Those are your answers. Okay? All right, now let's look at one that's a little bit different, that poses a little bit of different of a problem. 5 minus 4x absolute value minus 3 equal 4. Okay? Now, before I can change this absolute value problem where I do the two different problems, I must first simplify that part of it. So I got to take this over to the other side. Okay? To do that, that is plus negative. So here it was a negative, here it becomes a positive. And so that's a positive 3, which means I have 5 minus 4x absolute value equal 7. Okay, 5 minus 4x absolute value equals 7. So, once again, that's plus a negative. So I have 5 plus negative 4x equals 7, or 5 plus negative 4x equal negative 7. Okay, now it becomes the same thing we were doing. 5 here, it's a positive here, becomes a negative there. That would be negative 5. 7 plus negative 5 would be what? What would that be? What? 2. So that's negative 4x equal 2. Okay, negative 4x equal 2 means I have to divide by negative 4 to both sides. That cancels. X equal 2 over 4 reduces to negative 1/2. So that's your first answer. The other side, we do exactly the same thing. That becomes it's a positive here, it becomes a negative there. So now I have negative 5. Well, what is negative 7 plus negative 5? Negative 12 is equal to negative 4x. And what do we get when we do that? Well, we divide by negative 4 to both sides, and that gives me x equal 3. So my two answers are negative 1/2 and 3. Okay? Okay, now, let's look at the inequalities. Okay, let's look at the inequalities. We've talked, that was the equation part. Now we're going to look at the inequality part. Okay, now, there is on page 354, okay, everybody look at page 354. Look right in the middle where that table is at. It says solving absolute value equations and inequalities. We've already really covered, obviously, the equation part. I want you to look at the inequality part. Okay, let's look at the very first line there. It says the absolute value of a times x plus b is less than c. Okay, this means a times x plus b is less than c, and a times x plus b is greater than negative c. Okay, so the difference between the equations, okay, the difference between the equations and the inequalities is this part right there. Okay, we've done exactly the same thing. The difference is when I change the c to negative c, I must reverse the inequality sign. Okay, every time. Okay, so if that was they give you the other examples right there. The next example they give you has the less than or equal sign with it. Okay, the next one they give you is ax plus b less than or equal. Oops, that less than sign looked really bad. Like that. Well, that means ax plus b is less than or equal to c, and ax plus b is greater than or equal to negative c. Okay? Now, as with the equations, you had the or statement. Okay, we had the or statement. Now you have and or for the inequalities. Okay, now the reason you would have the and or, okay, the and or the or statement in inequalities is because we had it earlier when we were solving regular inequalities. Okay? We had that before when we were solving inequalities. Can't remember what section it is. Okay, I think it was 1 or 2, section 1 or 2 in this chapter. We had the and or statements. Okay? So let's look at an example. Some of these they're going to want you to graph. Okay? Some of them you don't have to graph. Okay? Not very hard to graph them, but let's just look at one. Let's look at number 46. Number 46 says 9 plus x absolute value is less than or equal to 7. Okay, and I want to show you what the difference between having an and statement and having an or statement. Okay, and I will show you how to graph both of them as well. Okay, so to do this one, we simply do this. 9 plus x less than or equal to 7. 9 plus x greater than or equal to negative 7. Okay? We don't really know if it's an or statement until you get to the end. Okay? Because of how the answer is. Alright? So, let's solve this one. It's the same way we solve. Okay? Here it's a positive. Here it becomes a negative. So that's negative 9 that I'm adding to positive 7. Okay, what is 7 plus negative 9? Negative 2. So that is x less than or equal to negative 2. Let's solve the other side. 9 here, it's positive here, it becomes a negative there. Excuse me. Okay, and so that's a negative 9 over here that I'm adding to negative 7. What is negative 7 plus negative 9? Negative 16. So x is less than or equal to negative 16. Okay, so which one is my smallest number? Negative 16. So I'm going negative 16 is less than or equal to x, which is less than or equal to negative 2. Okay? Now, can I put the x, in other words, x less than negative 2 is right here. X less than or equal to negative 2. X greater than or equal to negative 16 is x greater than or equal to negative 16. So I can make those two things function. They can mesh together. Okay? And so therefore, excuse me, therefore, that is just a regular AND statement. Okay? That is a regular AND statement. Now, the reason it's an AND is because if I graph it, if I graph that solution, okay, if I graph that solution, I've got to first of all have negative 16. So I'm just going to go by twos. Negative 16, negative 14, negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2. So if I was to graph that, I would simply do this. It has to be greater than negative 16. Okay? Well, that means it's going to go this way, is greater. So I'm just going to take it and go all the way to negative 2. And I'm going to color it in. Remember, the reason we color in the dot is why. Why do we color in the dot? Brandon. Right. It has the equal to, has the less than equal to sign or greater than equal to sign. Okay? Are all of my numbers contained in that line? Is all of the possible solutions to this inequality in this line? In other words, can I plug in 0? No, I can't plug in 0. I can't plug in negative 18. So since they're all right there, it's an AND statement. An AND statement looks like this. Now, if the answers were negative 16 and to the left and negative 2 and to the right, that's an OR statement. Okay? It's OR. It is X is less than negative 16 and x is greater than negative 2. Okay, that would be an OR statement. I can't have the numbers in between those two numbers. Then it's OR. Okay, it's not AND. An AND statement contains all of the answers in a certain line segment. Okay, that's the difference between the two. Can you tell right off the bat, is there a thing that gives it away? No, there's not. You have to solve it and then see where your answers lie. Let's look at an OR statement. Let me find one here. Let's look at number 54. The answer is this and that. Okay? Like I said, some of them they're going to say solve the inequality. Some of them they're going to say solve and graph the inequality. That's number 46 that we just did. Number 46, the directions say solve and graph, so you got to do both. Okay? For that to be correct. Let's look at, I think it was, let me look at 54. Okay? Let me see if 60 is an OR statement. Yeah, let's look at 60. I'll look at the hardest one. Number 60. Okay? Number 60 says 3x minus 9 absolute value plus 2 greater than 7. Wow. My greater than signs are not looking, greater than less than signs are not doing real well today. Yeah, they're not looking great or less. All right. So, first things first, I've got to take this over to the other side. So that gives me the absolute value of 3x minus 9 is greater than 5. Anybody not understand where I got the 5? It was positive. Let me pull this down a little. It was a positive here. It became a negative there. So I had a 7 plus negative 2 is how I got the 5. Okay, I'm assuming that you understand that part of it. Now, we have 3x minus 9 is greater than 5. And then we have 3x minus 9 is less than 5. Negative 5, excuse me. Less than negative 5. Okay? The key is to make sure that you do both of those things. That you reverse the inequality sign and you do the opposite of the number over there. Now, obviously, on these, on an inequality, the number that's by itself can obviously be a negative. Okay? When it's like this. Okay? Because you got another number there besides just the absolute value. Okay? All right. But the rest of them are going to always be on the right side of the equal sign or equality sign is always going to have to be a positive number. Because we've already said, somebody just asked it, I think Zach did. Zach just asked the absolute value, how is it negative? You can't have the absolute value of something to be negative. Okay, that's impossible. Okay? So when you've got an absolute value, and whether it's greater than or less than, the number to the right of it is always going to be positive. Okay, to start off. All right. Now, we solved these two. Hey, I'm going to tell you right up front, you're going to come up with fractions. Okay? So, we solved these two. I'm going ahead and change that to plus and negative. Plus and negative. I'm going to take that negative 9 over here, and it becomes a positive 9. And that gives me 3x is greater than 14. I'm going to do the same thing over here. I'm going to take that negative 9 and put it over here. It becomes a positive. Okay, and that gives me 3x is less than It's less than what? 4. And it would be positive 4. Okay? Now, I'm going to take and divide by 3. Divide by 3 to both sides. Excuse me. Okay? And that gives me x is greater than 4 2/3. Correct? Okay? And then that gives me x less than 1 1/3. Okay? So, can I take and put my smallest number, 1 1/3, and put it like this? Is that a true statement? No, that's not. Okay? But that is an and statement. Okay? 1 1/3 less than x, or yes, is less than x, less than that. I can't write that. That's not true. That's not what these two things say. Okay? Because I can't write 4 2/3 less than x. I can't do that either. Okay? So, because I can't go larger to smaller, I always have to go smaller to larger. Okay? So, this would be an and statement. But we just said that and statement is wrong. So let's graph it. Okay? Let's go with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's graph the first one. X is greater than 4 2/3. So, x is greater than 4 2/3. That would be that. X is less than 1 1/3. So, there's your OR statement. Okay, the numbers between the 2 points are not solutions. The numbers between our 2 points, our 2 dots that are not colored in because we didn't use the equal sign, the numbers in between the 2 dots are not solutions. Therefore, it has to be an OR statement. Okay? Once again, right up front, there's not, oh yeah, it's going to be an OR statement. No, you can't do that. Okay? You might be able to see it on a little simple problem, but most of the time you can't. Okay? So, okay, now let's see here. Let me make sure what I just read is correct. Yes, okay, good. All right. All right, now, just read a little deeper. You can actually say, if okay, it will be an OR statement, and that's what, if you go back to your box, the little green box, underneath the green box, it tells us that, and you will see it in the actual example. I was just looking at the examples wrong. Okay, it will be an OR statement if you use a greater than or a greater than or equal to sign in your original inequality. Okay? If so, then if it is a less than or less than or equal to sign in the original inequality, then it's going to be an and statement. Okay? In the original absolute value inequality, if it is a less than or equal to sign, it's going to be an and statement. If it is a greater than or equal to sign, it's going to be an or statement. Okay? All right. So your homework, once again, is 6.4, 1 through 68 even. Okay? 1 through 68 even. Now, on 61 or 62 and 64, they just want you to write an absolute value inequality. You don't have to actually solve it. Okay, so they're just wanting you to give them an inequality, an absolute value inequality that would satisfy the problem. Okay, on 66 and 68, you're going to have to do a little thinking. I believe there's a little bit of solving, but not a whole lot. Okay, so on 46 through 60, you must have the graph. All the other ones, you don't have to. Okay. The graph will be tied to your answer. It will only be 1x. All right.